Okay, we're going to look over lesson 21, factoring polynomials. But first, I want to start with some algebra tile work and to see how we got here in the first place. So imagine that we have x plus 2 times x plus 3. Let's build that with our algebra tiles. So remember, these are our x's, and these are our units. So we're going to have 1x and 2 units across the top. And then on this side, we'll have the second one, this x plus 3. I'm using the green and the white sides because those are the positive sides. We'll do negatives, but not today. So when I multiply an x and an x, I'm going to get an x squared. Do you see how this side matches and this side matches? Now when I multiply an x times a 1, I will get another x. And it fits right in there like this side times this side. And then another x times 1. And then down here I have an x times a 1, 3 times. So these all fit right here. And then here I have 1 times 1. So I'm going to get all my little bitty squares, and I'm putting them in here. Another 1 times 1, and I do that 2 more times. So now we just have to count them all up. These were our factors. When we multiply that together, we get what's inside here. So that's why I have this pink paper. This is our answer to our multiplication. I have an x squared. I have 1, 2, 3, 4, 5 x's. And I have 6 1s right here. So let's review how we've done this before just on paper. We've done the FOIL method. And when I do, the F stands for the first, so that'd be the first ones in each parentheses, x times x, which is x squared. The O stands for the outside, x times 3, which is a 3x, and it's positive. The I is the inside ones, 2 times x, which is a 2x, and it's a positive, so we'll add it. And then the L stands for the last ones in the parentheses, that's 2 times 3, which is 6. And then you can see our outside and our inside ones were our 2 different x values, so there's something x. So that's a 3x and a 2x, and we're going to add that together. So x squared, 3x plus 2x is a 5x plus 6. So that is the same thing that we got when we did our algebra tiles. So let's do another one. Okay, so I'm going to clear my middle section. Across here I have an x plus 2, and then down I'm going to have x plus 5. So when I multiply these, this one is going to need an x side times an x side. That's going to give me my x squared. This one is 1 times an x, and another 1 times an x. And then here, same thing, this is an x, and then I just have 5 1s. And then here I have a 1 and a 1, and then all these ones, so I just need to fill in. I have 2 across and 5 down. So now inside of here I have a rectangle because I've covered all of this side and all of this side, and I've made it a rectangle of length. This one is x and x, and this one is a 1 and an x. So I'm going to count what I have in here. I have 1x squared. I have 1, 2, 3, 4, 5, 6, 7 x's. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the ones. Remember that these are my factors, so they don't count when I'm adding up the total. Now we'll do this as a FOIL. So my first ones are x squared. My outside one is a 5x. My inside one is a 2x. And my last is a 10. When I add these all up, you can see that I get x squared plus 7x plus 10. Remember that Matthew C. also taught a way of stacking them on top of each other. Just like when I multiply something like 21 times 34, I do this 4 times 1 and the 4 times 2. If I were to stack these on top of each other, I would start with the 5, and I would do 5 times 2, and I would do 5 times x. And then, just like in here, I do the 4 times 1 and the 4 times 2. Then I put a placeholder, and that's because now I'm in the tens column, not the ones column anymore. So I move over to the tens column, and I do 3 times 1 and 3 times 2. The same thing here, I've used this 5 in this one, so I put my placeholder in, and then I do x times 2, and I do x times x. And you would then add down, just like in this one, you would add down to get your final answer. And you see that no matter whether I do it this way, whether I FOIL, or whether I use my algebra tiles, I'm getting the same answer every time. But now we have to think about what happens if we wanted to go backwards. Let's say we don't know what the factors are, and I'm going to use the same problem so that you can see it. Okay, so we have our answer, but now we want our two factors. So what do we multiply together to get this? Well, since we just did this problem, we can see it a lot easier. I have all of these tiles, you know, maybe I even line them up like this. Now I need to make them into a rectangle, because that's how I can get my length times my width, or, you know, the area of the rectangle. So I have to make these into a rectangle. So because I just did it, I kind of know how to do it right. These two, and then 5. If you like to smush them all together so you can really make sure you're doing this accurately, or if you like them spaced out and pretty, however you want to put them on here. Okay, so now I've made a rectangle. So now I got to say, well, how big is it across this side? Well, it's an x length here, and then it's 2 exactly. And then on this side, it's an x length, and then it's 5. So those are going to be my two factors. This is x plus 2, and this is x plus 5. So now let's try one that we don't know the answer to. We have x squared plus 4x plus 3. So I'm going to get those tiles out. I have an x squared. I'm going to have 4 of the x's. And then I want 3 of the units. How can I arrange these in a rectangle so that it's an exact rectangle, but it doesn't have missing pieces or extra pieces? So I might, you know, be trying something like, okay, well, this is a rectangle, and then I have these 3 pieces, so I'll put them right here, because that seemed to be where those ones ended up. But that, I mean, I've got some holes here. It's not making a rectangle. What if I move this one, and it looks like it would fit right here? Now I have a rectangle with all my pieces. So what are the factors? What did I have across the top and across the side to make that rectangle? Across the top, I have an x, and then there's 3 units. And across the side, I have an x and 1 unit. So here I have x plus 3, and here I have x plus 1. So that's a way to use the algebra tiles to do this. I know you don't have algebra tiles at home, but maybe you have the Matthew C tiles, or maybe you just have, you know, this could be a 100 block and a 10 block. Just make sure that you don't get into the pattern of trying to do your ones all the way across here, because in the algebra tiles you can see that it's not exact. It does not make an exact number. So because this is an X value, we don't know exactly how many of these it would make. We need to use the X length tile. But if you're using other blocks, maybe a 10 block and a 100 block, it would fit exactly 10 of them, but that's not what you want to do. So make sure that you're just using the long ones against the squares. Let's try one more, and then we'll work it on paper. So x squared plus 6x plus 8. So I have an x squared. I'm going to need 6 x's. And then 8 ones. So there's 5, 6, 7, 8. Okay, how can I put these together in a rectangle? Remember, I don't want to do it this way, where I put them like this, because these are units and this is an x, and we don't know how long it is. So you need to turn your x's so that they're against the x length. I'm going to have some of them here. And then these would go against the 1 length. This isn't really working out for me, so let's see. If I move these over, if I move this one down here, still not quite a rectangle, so maybe I move this one down here, and there we go. We found our rectangle. So what are the factors across the top and the side that made this rectangle? I had an x here, and then I have 4 little pieces across the top. So x plus 4, and then this one was an x with 2 more. So x plus 2. Now we're going to transition to how we do this on paper, because we run out of algebra tiles to get some big ones going. So now we're going to work on some of these on paper, and these are going to follow your notes. Example 1, it says factor x squared plus 3x plus 2. So I'm going to give you some thoughts as to how we can factor this on paper. Algebra tiles are going to work great, but let's see how we actually got there if we're working on paper. So first, I'm going to look at this. My highest power of x is an x squared. So I know I'm going to have 2 factors. So I'm just going to put my parentheses out because I have 2 factors. And then I look in front of this x, and I see there's a 1 there. So the only thing that can give me 1 is 1 times 1. So 1x times 1x. Because remember, this came from our first. So we're multiplying these first 2 to get this one right here. Now the numbers that go here are what I multiply to get my last. But then I have to do my outside and inside to get this in the middle. I do note that both of these are positive, so at least I'm not working with negative numbers, because that gets just a little more complicated, a few more choices. If this is my last, that means these 2 numbers have to multiply together to give me 2. So what are our options there? 2 times 1, or 1 times 2. But in this case, I'm going to be multiplying them by an x every time. So 2 times 1, let's just put those in there, and then I'm going to check it. My or my outside ones, is going to be 1x plus 2x. Is 1x plus 2x equal to 3? It is. So I'm finished. Let's try example 2. Factor x squared plus 7x plus 12. So I see that my power is x squared, so I have 2 factors. I see that everything is a positive, so I know that I'm going to have a plus in between these. I don't have to deal with minus signs. And I see that my x squared doesn't have anything in front of it. So the only way to get the 1x squared is to have 1x times 1x. Now I'm looking for my factors of 12, because that's what could go here. We have a lot of choices there. 1 and 12, multiply together to be 12. 2 and 6, or 3 and 4. So how do I know what numbers to put here to make this work? Remember, this is my OI, my outside and my inside. So whatever I put here, I'm going to be multiplying by an x, and then I'll be multiplying this one by an x, and then they have to add up to be 7. So since my x has just a 1 in front of it, I can think about just these factors. They'll be multiplied by 1, so they won't change. So does 1 plus 12, that's 13. That's not 7. So those don't work. What about 2 plus 6? That's 8. Not 7, doesn't work. 3 plus 4. There we go. Right now, since we have an x in both of these, it does not matter if we put the 3 here or the 4 here or the 3. So our two factors are just x plus 3 and x plus 4. How about example 3? We have x squared plus 8x plus 12. And I want to factor this. Again, I see that I have x squared, so that means two factors. Everything's positive, and there's no coefficient here. So I'm going to get an x times an x. These are my first ones to get my x squared. Now I'm going to go to my last ones. Factors of 12. Oh, we just did that. We have 1 and 12, 2 and 6, or 3 and 4. But which ones are going to add up after they're multiplied by the x's will be 8x when I add them up? Well, not 1 and 12, and we just did 3 and 4, that was 7. So we're looking at this set of 2 and 6. And again, everything is positive, so we're working with positive numbers here. All right, last example on the paper. X squared plus 6x plus 8. X squared means I have two factors. There's no coefficient here, so I know that x times x is what's going to give me x squared. Those are my first. My last one's right here is 8. Now I have a couple choices, 1 and 8 or 2 and 4. So when I put them here, if I put a 1 and an 8 and then I multiply them by x's, I'm going to get 1x plus 8x. That doesn't give me 6. If I put a 2 and a 4 here, I would have 2x plus 4x. Well, 2 plus 4 does give me 6. And I was saying plus, and they are all positive. So those are our two factors. If we want to check ourselves, we can just go back and do the multiplication here and make sure that we get what we started with. So we're trying to get to this multiplication answer when we multiply these two factors. Our first one is x times x, which is x squared. Our outside is x times 4. Our inside is 2 times x. And our last one is 2 times 4. We add them all up. These two are our outside and inside. Remember, I kept saying this was my OI term, or my outside and inside, because these two add up together. So x squared plus 6x plus 8, and that is what we started with, so we factored it correctly. So just to relate it back to this, we have right here, we had x plus 4 times x plus 2. When I laid them out, when I multiplied this 4 times the x, I got 4x. That's this one right here, my outside term. When I multiplied this x times the 2, that's my inside term right here, I got the 2x. And then the 4 and the 2 multiply together to be my last term right here is my 8. And my first two was an x times an x is my x squared. So that's how this picture relates to what we're doing, how we're foiling and unfoiling. Foiling would be multiplying them together. Unfoiling would be finding the factors.